Why are latent and sensible heat loads tricky? HVAC systems. Imagine trying to keep a room perfectly comfortable, but the challenge is that heat isn't just about temperature. It involves two different kinds of heat that work together and sometimes against each other. That's what makes managing heat loads in heating, ventilation, and air conditioning systems so tricky. Sensible heat is the easy part. It's the heat that makes the air warmer or cooler, like turning on a heater or air conditioner. When you change the temperature of the air, you're dealing with sensible heat. It's straightforward to measure because it depends on the temperature difference and how much air is moving through the system. Latent heat is a different story. It involves moisture in the air, like humidity. When water vapor condenses into liquid or evaporates into vapor, it absorbs or releases energy. This process doesn't change the air's temperature but affects how humid the air feels. Managing this is more complicated because it's about controlling moisture, not just temperature. In HVAC systems, both types of heat are happening at the same time. For example, when you cool air in a humid climate, you need to lower the temperature and remove moisture. This means the system has to handle both sensible and latent loads simultaneously. If you ignore the latent part, the space can feel damp or clammy, even if the temperature is right. Calculating these loads is another challenge. Sensible heat can be figured out with simple math using temperature and airflow. But latent heat requires measuring moisture levels, which is more complex. Engineers use psychrometric charts or equations to find out how much moisture needs to be removed. This makes system design and sizing more complicated because you need equipment that can handle both loads properly. Removing latent heat often involves condensation, which releases heat. So, the cooling coil not only cools the air but also condenses water out of it. If the system isn't designed well, it can end up using more energy or not removing enough moisture. That's why understanding the difference between these heat loads is so important. Another tricky part is that outdoor weather conditions change throughout the day and seasons. High humidity days requiring more dehumidification, which adds to the load. HVAC systems must adapt quickly to these changes to keep indoor conditions stable. This requires smart controls and properly sized equipment. In practice, engineers use psychrometric charts to analyze air properties and determine the right size of cooling coils and dehumidifiers. They also consider internal moisture sources like cooking, bathing, or even plants. Properly managing both heat loads ensures comfort, saves energy, and prevents issues like mold. So, the reason latent and sensible heat loads are tricky is because they involve different physical processes, requiring precise calculations, and demand equipment that can handle both at the same time. It's a balancing act that needs careful planning and understanding of psychrometrics and HVAC system design.